The sun. Calm, warm, life-giving, except when it suddenly bursts with radiation and plasma, sending a storm hurtling through space. These outbursts, called solar flares and coronal mass ejections, can hit Earth with some serious consequences. But how do they work? And what would happen if a really big one came our way? The sun may look solid, but it's actually a swirling ocean of superheated plasma. This plasma is so hot that it rips apart atoms into free electrons and nuclei, creating a chaotic, electronically charged environment. Because plasma is made of charged particles, it interacts with the sun's magnetic field. But here's where things get interesting. This movement doesn't just follow a simple pattern. Instead, the sun's magnetic field is constantly shifting, twisting, and tangling as the plasma churns inside it. Imagine a giant tangled ball of rubber bands. The more they twist, the more energy they store. And then suddenly, snap. The energy is violently released. That's exactly what happens when the sun unleashes solar flares, sending waves of high-energy radiation and massive clouds of plasma hurtling through space. If a solar flare is aimed at us, things can get interesting, and fast. A solar flare travels at the speed of light, meaning it reaches Earth in just over 8 minutes. While our planet's atmosphere blocks harmful radiation from reaching the surface, the blast can disrupt satellites, GPS signals, and radio communications almost instantly. A coronal mass ejection, on the other hand, takes anywhere from a few hours to a few days to reach Earth. When it arrives, it collides with our planet's magnetic field, triggering a geomagnetic storm. Most of the time, this energy is safely redirected towards the poles, creating the stunning auroras we love to see. But sometimes the storm is too strong. Instead of just making the night sky glow, it can cause electrical disturbances on a massive scale. In 1859, a massive solar storm known as the Carrington Event struck Earth. This was before modern electricity grids, but even then, it caused telegraph systems worldwide to fail, shocking operators and even setting some telegraph offices on fire. Fast forward to today, our world is now completely dependent on electricity, with power grids stretching across the globe. If a storm that powerful hit now, the surges could overload transformers, causing widespread blackouts. It's already happened on a smaller scale. In 1989, a solar storm knocked out Quebec's power grid, plunging millions of people into darkness. That was just a fraction of what a truly massive event could do. Let's talk about worst case scenario. In 2012, a solar storm as strong as the Carrington Event just barely missed Earth. Had it hit, experts estimate it could have caused trillions of dollars in damage. Power outages could have lasted for years in some regions, leading to a domino effect of failures. Without electricity, there's no communication, no running water, and no way to transport goods efficiently. Food supplies could dwindle, hospitals would lose power, and entire cities would become unlivable. And here's the unsettling part. Scientists estimate there's about a 50-50 chance that a storm of this magnitude will hit Earth in the next 50 years. But it gets even scarier. A 2019 study found that even quiet stars like our sun can produce superflares, eruptions that are hundreds of times stronger than anything we've ever observed. If one of those were to hit Earth, the consequences would be catastrophic. Now, before you start digging a bunker, here's the good news. We can prepare. Unlike other natural disasters, solar storms are predictable. Scientists constantly monitor the sun and can detect when a coronal mass ejection is on the way, giving us hours to days of warning. That's enough time for power companies to take protective measures such as shutting down key systems and redirecting power to prevent overloads. Governments and industries around the world are working on solutions to strengthen our power grid against these storms. With relatively simple investments, we can protect transformers and substations, reducing the risk of long-term outages. The bottom line? While we can't stop solar storms, we can minimize their impact and prevent civilization from grinding to a halt. The sun gives us life, but it also has a wild side. The question isn't if another big storm will happen, it's when. And the good news is that with preparation, we don't need to panic. We just need to stay ahead of the storm. If you found this video interesting, don't forget to like and subscribe for more deep dives into the science of our universe. See you on the next one.